In this project, I will demonstrate how to use GPIO pin write function to control optocoupler relay. Open Escape Studio and click on this file icon, then select New, then select Renesas C++, then select Renesas RA project. A new dialog box will appear. You can give name to your project here. After naming your project, click on this Next button. From this drop-down menu, select FPB-RA0E1 board and click on Next button. Select Executable and No Autos option, then click on Next button. Here select Bare Metal Minimal and click on Finish button. IDE will take some time to configure your project. After project creation, open FSV configuration file. I am using D6 of Arduino interface to control optocoupler relay. According to this quick start guide document, D6 is connected to P102. Open FSV configuration file and click on Pin tab. Here expand P1. Now select P102 and change its mode to GPIO output mode. In pin setting, you can select output mode, initial low and high according to your preference. Now I will use onboard user switch to send control signal to optocoupler relay. When the user switch is pressed, we will send high signal to optocoupler relay, and when user switch is released, we will send low signal to optocoupler relay. P200 is used as user switch. Disable interrupt on P200 and enable input mode, then click on generate project contents. Expand src folder, then open hallentry.c file. Define while1 loop here, then declare BSP IO level variable. Now in Project Explorer tab, expand Developer Assistant tab, then expand GPIO stack. From this drop-down menu, drag and drop pin read function call in while1 loop here. In second argument, you need to give pin name defined in FSP configuration file. For third argument, you need to specify BSP IO level variable here. Now define FSP error variable and use assert function to make sure pin read function call was successful. Now use if statement to check for pin state variable. Now according to your preference, you can control relay pin in if condition. By design, user switch is pulled up, so I am sending a low signal to relay pin when user switch is released. From developer assistant menu, drag and drop pin write function call in if condition here. For second argument, you require pin name defined in FSP configuration file. You can open FSP configuration file and copy the symbolic name given to P102 in FSP configuration file. Now use BSP IO level low variable to make the relay control pin low. Now use assert function to make sure pin write function call was successful. Now in else condition, we can make relay control pin high. You can copy pin write function call from if condition and paste it in else condition. Now change the BSP IO level to high. Use assert function to make sure pin write function call was successful. We don't need to change anything further. Now click on your project name, then click on this hammer icon to build your project. We need to specify the address of BSP-IO level variable in pin read function call here. Now again click on your project name, then click on hammer icon to build your project. Now right click on your project name, then select debug as, then select Renesas GDB hardware debugging. Click on switch button to switch to debug perspective. In debug perspective, click on the zoom button twice. As you can observe here, when I am pressing the user switch, LED will turn on. That's mean a high signal have been received on relay control pin.